Determine the forces in all the members of the complex truss. State if the members are in tension or compression. To solve for complex trusses, we have about 4 steps to do. Our first step is to eliminate any joint that has 3 or more unknown forces. So in this case, we can remove member AD and substitute it with a new member at joint E and C. Once we have the member, now we can find its angle. We're going to name it angle theta. To find angle theta, we need to determine the total length of member E along the total line all the way to the E. To do that, we just need to find our length between member or joint FD and the joint E. So it's going to be 1030 down 6 feet, and it's going to give us the length of this portion of this member EB. So this comes up to be 3.46. Now we can find our angle theta, so it's simply going to be tan of 12 plus 3.46, it's 15.46 divided by the width, which is 6 feet. And angle theta comes up to be 68.79 degrees. Now that we have that, now we can find our external reaction forces. We can find our x-axis by simply adding forces along the horizontal line or in the x-axis. So this is simply going to be 600 pounds and negative ax all equals to 0. And our ax is 600 pounds. Now we can take a moment about the point E in order to find our value for reaction force Cy. It's going to be Cy 12 feet away, counterclockwise and then clockwise, 600 pounds, 15.46 feet away, all equals to 0. So for Cy, we get our solution as 733 pounds. Now we can sum the forces in y direction in order to find our solution for reaction force Ay. Negative Ay, positive Cy, all equals to 0. So for Ay, we get a solution as 733 pounds as well. Now that we have done that, we have our external reaction forces. We can start determining our force in each member. Starting with joint A. At joint A, we have external reaction Ay, horizontal reaction Ax, unknown vertical at member AF, and then we have another unknown at member AB. To solve this, let's sum the forces in x direction in order to find our solution for force in member AB. So we can have negative 600 pounds and then negative horizontal component of force AB, which is cos 45 times force AB, all equals to 0. So for force AB, we get a solution as negative 848.52. Rounding it up, we get 53 pounds. And because we got our solution negative, this means we assumed our vector direction in the wrong direction. Switching it over, we get a solution in positive, and this also tells us that this member is in tension. Now we can sum the forces in y direction to find a solution for force in member EF. We can have positive EF force EF, negative EY, and then negative vertical component of force AB. Solving for force AF, we get our solution as 1333 pounds. Now we can proceed to our next joint, joint B. At joint B, we have our unknown force from member BC and E, and our known from force A. Now sum the forces in extraction to find our solution for force BC. So we can have horizontal component of force AB and then the horizontal component of force BC. Solve for force BC, we get a solution as 848.53 pounds. Now we can sum the forces in y direction to find our solution for force EB. So we're going to have vertical component of both member AB and member BC's force. And we get a solution for force EB as 1200 pounds. And one thing I forgot to mention, that all these new forces we are finding, you're going to name them as prime. And the reason being, when we solve for complex trusses, we have to use superposition, and we have to use the following member force formula in order to find a solution for each member in the truss, where I simply means the iteration of the member of the trusses. Alright, now that we have all the members for joint E, we can proceed to joint F. At joint F, we have known force in member AF. Then we have unknown member FE, and our other unknown is member FC. Our angles here are 45 degrees and 30 degrees. We're going to have simultaneous solution for this joint. So let's sum the forces in extraction. Find our solution for FC and FE. We can have horizontal component of force FE and FC. Since we have two unknowns, we're going to solve for one, and in this case I'm simply going to solve for FE, and we get a solution as 0.816 times force FC. And they're negative, so that means we zoomed our vector in the wrong direction. But we're not going to solve it just yet, because otherwise we have to switch everything in our equation, our equilibrium equation for x-axis. We're going to keep it as it is, and then we're going to proceed to our y-axis. All equals to 0. Now we can plug equation 1 into equation 2. Solve for force FC, we get a solution as 1195.40 and negative. Now we can switch our signs. For force FC, so we can change it over to this positive solution, and this also tells us that this member is in tension. Even though this is not our final answer, we don't really have to tell if it is in tension or compression. But it's a good practice. And now we can plug the value of force FC into equation 1. Solving for force, remember FE, we got a solution as 975.45 pounds. And this means this member is in tension, and pardon me, I don't know why I said it's in tension, it's in compression. S prime FC. Now looking at our structure at joint D, this member ED and member DC will be zero force members since we have eliminated AD in this scenario, and therefore we just need to find RE. For that, let's draw the free body diagram. Joint E, F are known vector, EF then our known vertical force. Remember EB 1200 pounds, and then our unknown number EC. This is our angle theta we found at the beginning. Now let's sum the forces in y direction to find a solution for EC. So it's simply going to be sine 30 degrees negative times 975.45 pounds positive 1200 pounds and then negative vertical component of EC. We get our solution for EC as 764.03 pounds. Now that we have found all our S primes, now we're gonna remove all the external forces from our truss. And find our SI for each member. This will help us determine our X. Which is our magnitude. Let's redraw our diagram, and we're gonna have applied load of 1K at joints where our member AD was. Alright, so everything else is exactly the same as it was before. And our angle here for the new applied loads is 45 degrees because that was our angle for member AD. Okay, let's start at joint A by drawing its free body diagrams. With joint A, we're going to have our unknown force AF, our known applied at a load of 1K or 1000 pounds, and then we have our unknown force in member AB. So now you can start by summing the forces in x direction. So we're going to have horizontal component of applied load and then horizontal component of unknown AB. So for AB, get our solution as negative 1000 pounds. That means we zoomed our vector in the wrong direction. I'm going to switch it over. And also remember, this is our small s. And this member is in compression. And looking back, our S prime AB was in tension. Now we can sum the forces in y direction. So we're going to have vertical component of AB, then we're going to have vertical component of applied load, and finally our unknown EF. Following for EF, we get our solution as negative 14.21 pounds. Negative means we assumed our vector in the wrong direction. So check it over, gives us our correct solution, and also tells us that this member is in compression. Okay, now that we have that, we can move on to joint B. At joint B, we have our known member AB, our unknown. Pardon me, we don't have our. We didn't have EB, which I missed. I should have drawn it, so I'm going to draw it right now. So we're going to have our unknown EB and our other unknown. BC. Now we can sum the forces in extraction to find a solution for force BC. Simply going to be sine 45 degrees times 1000 pounds, and then going to have negative sine 45 degrees times the unknown force BC, all equal to 0. We get the force BC to be 1000 pounds as well, and in compression. Now we can sum the forces in y direction. Y, we're going to have both vertical components, so it's 2 times cos 45 degrees times 1000 pounds. And then we can have positive unknown force EB, all equals to 0. So for EB, we get a solution as 1414.21 pounds. Now we can proceed to directly join T. At T, we have our applied load of 1000 pounds, our unknown force DC, and for unknown force ED. We can begin by summing the forces in extraction. You're going to have horizontal component of force ED and the horizontal component of force, the applied force, equals to 0. We get a solution as 816.49. Rounding it up, we get 5 pounds. Now we can do the same for our y direction. So you're going to have unknown force ED, DC, and the vertical component of applied load and the force, remember ED. And we get a solution as 1115.36 pounds. Now that we have solved for D, we can proceed to joint E. Pardon me, we don't even need joint E. We just need joint F. So we're going to proceed to joint F instead. At joint F, we have our known force AF, then we have the unknown force FC, and finally the unknown FE. Like before, we're going to have simultaneous solution for F. So let's start with X traction. We're going to have horizontal component of FE, and then we have the horizontal component of FC. Now we're going to do the same for y-axis. We have known AF, 1414.21 pounds. Then we have the vertical component of FC, and then we have the vertical component of EF, all equals to 0. Now we can plug the values of equation 1 to 2. So for FC, we get a solution as 1268.23 pounds. Now we can plug the value of FC into equation 1, and we get a value for EF as 1034.87 pounds. FC is in tension, EF is in compression. Alright, now that we have F, we can go to joint E. The following is information is from our previous page. So at E, we're going to have force EB, which we found to be 1414.21 pounds. Then we have our FE, which we found to be 1034.87 pounds. Then we have our unknown force EC and a recently found force ED, which is 816.5 pounds. Alright, now we can sum the forces in extraction to find a solution for unknown member FC. It's going to be horizontal component of EF and ED, and also the FC. We get our solution for FC as 522.72 pounds. Cos is negative, we need to switch our vector direction, giving us positive, and it also tells us that this imaginary angle would be in compression. Now that we have found both our S prime and our other S, we can use our formula which we discussed earlier, in order to find our solution for x, which will tell us the magnitude of. To find it, the force in member EC needs to be 0. So we're going to, first of all, let's write our formula. S equal to S prime I plus X times SI, which is simply going to be our EC with the external reaction forces. We found it to be 764.03 pounds, and then we have our X, which is unknown, and our petite S we found for EC as 522.72 pounds, all equals to 0. Solving for X, we get our solution as negative 1.46. Now since we know our X, now using the values of the S prime and the petite S we found earlier, we can find our forces in the member of this complex truss. So our member AF is going to be 1033 pounds plus our negative 146 times the petite AF we found, which is 14.21 pounds. Solving for this, we get our solution as negative 731.76. This tells us that our member is in compression. Because we took care of the signs already, we don't have to worry about it. So if we get negative now, it simply means compression. Positive means tension. Now the force in member AB. For AB, we've had 848.53 pounds plus negative 1.46 times petite AB, which was 1000 pounds. And solve this, we get negative 611.47 pounds. And this number is in all compression as well. Now we can proceed to force EB. We found S prime EB to be 1200 pounds, and that 1200 pound was in compression. Then we have a petite EB, which was in tension at 1414. Now we get our solution as 1864.75 pounds, and it's in negative, so that means our second half of the equation is still prevailing, and this tells us that it's in tension because our petite EB is in tension. Our S prime force BC was 848.53 and petite BC was 1000 pounds. In compression, solving our solution, we get negative 611.47 pounds, and it's in compression again. Now we are moving to next number, which is FE. So our S prime FE was 975.45 and the petite was 1034.87 pounds in compression. And 975 was in tension. All this we got a solution as negative 535.46 pounds. And once again, it's going to be in compression. Now we have force member CF. S prime CF is 1195.40 and petite FC is 1268.23 pounds in tension. The other one was compression. Solve for CF, we get a solution as negative 656.22 pounds, and it's in tension. Now we have ET, which is only our petite S. It was in compression. We get our solution as negative 1192.09 compression. And finally our last member, BC. For capital we have 848.53 pounds, and for petite it's 1000 pounds. Capital it's in tension and petite it's in compression. And we get our solution as negative 611.47. With that we have our forces in the member, and now we can use them at joint A to find the solution for force in member AD. So let's draw our free body diagram for A once again. We're going to have the external reaction forces AY, we have AX, they have unknowns. Well, in this case, now we know force AF, which we found to be in compression, and it's 731.75 pounds. Then we have the unknown force AD and our known force in member AB, 611.47. We can sum the forces in X fraction because it's a little bit easier to find a solution for our known member AD. So we're going to have 600 pounds negative and horizontal component of AD and AB. Solving for force AD, we get a solution as 1459.998. Rounding it up, we get 1460 pounds.